Okay, to work this problem number 4, use trigonometry to find the normal force. First, we need to draw a diagram so we have an idea of what we're working with. So there is our surface at an angle, and it's an estimated 20 degrees. Here's the ground. And let's mark that angle with the surface of the earth as 20 degrees. So let's put our 10 kilogram box up here on the surface. Real quick, draw that out. So we have a 10 kilogram box sitting on the angled surface, and the measure of that angle that the ground makes with the earth is 20 degrees. My mouse does not want to write. Okay. And let's go ahead and label the mass of the box. Okay, so now we have a basic diagram drawn. Now we know from our definition of gravity that gravity pulls an object straight down toward the center of the earth. Okay, so we want to draw a line that is straight down from the center of the box to what would be considered the center of the earth, tangent or perpendicular to the surface of the earth. And that is the force, that line represents the force of gravity. So let's label that. This is actually an arrow for a force. I'm not going to get subscripts here, so let me just use a regular G. Okay, that arrow represents the force of gravity. Okay, but if we notice, this force is not pulling straight down onto the surface, and it's not pulling straight down the hill. It's a combination of those two. We actually have part of the force pulling straight down onto the hill, and another part of that force is pulling down the length of the hill, pulling the box forward, making it move, or making it want to move depending on friction. If we look at some geometry, we can see that the angle that the ground makes with the earth, as we found out in number 3, is the same as the angle that the force of gravity makes with the perpendicular, with the normal force. So we can actually go ahead and label that since we proved it in the last problem. So this angle is also 20 degrees. Okay, so now that we know the angle, and we know this line, we could actually move down here to form our triangle that we know how to deal with with our work with projectiles. Now we have a triangle that shows us the vertical force and the horizontal force, and we know the force of gravity, or we can definitely find it. Okay, so since we know force of gravity is equal to the mass multiplied by the acceleration of gravity, that's going to be, the mass is 10.0 kilograms times the acceleration of gravity of 9.8. meters per second squared will give us a force of gravity of 98 newtons. So we know the force of gravity, or the hypotenuse of our triangle, is 98. In order to find the force pulling straight down, the vertical force, if we look at our angle, that is the adjacent side of that triangle. So if we want to know the part of the gravitational force that is acting vertical to the surface the box is on, which will be equal to the normal force. Okay. So the normal force is equal to 98, the hypotenuse of our triangle, times the cosine of 20 degrees.